Okay, so let's look one simple application of the adiabatic process and its relationship with the isothermal process, because you see isothermal and adiabatic are so similar. We would want to see how they look on a PV plot. So let's draw a PV plot in here. So this is V pressure. So let's assume you have this, and you have another process, which is this. Okay, in both of these processes, you're moving from a pressure P1 and a volume V1 to a similar volume V2. But as you can see, the area under the curve in both these are different. And this one of these represents an isothermal process and the other one represents an adiabatic process. Okay? Now, we know that Cp by Cv is greater than 1. Why? Because Cp is greater than Cv. Okay? So if you have a process in which this is gamma, and if you have a process in which this is 1, so which of these is supposed to be more steeper? Now the steeper curve will be the one in which you have gamma, which is greater than 1. So which of these is a steeper curve? The steeper of these two is the purple curve, right? So this process represented here, which has a steeper curve, is the adiabatic process. And the green is the isothermal process. One is PV is equal to constant and the other is PV to the power gamma is equal to constant. The steeper one is always the adiabatic. Now, the amount, the area under the curve of the isothermal is greater than the area under the curve in the adiabatic. So in an isothermal process, so you do more work. In adiabatic, you do less work. You're coming down from the same P1 V1 to the same V. So you're coming to the same V2. So in here, you are coming from a P1 and a V1 to, you're coming down to V2. Similar is happening for the adiabatic, but the difference is that in an adiabatic process, you do less work. Because, as you can see, there is less area under the curve in here. And as compared to the isothermal, you have less work in the adiabatic and more work in the isothermal process. But the curve which is steeper is the adiabatic one and not the isothermal. Okay? Now, let's see one more example. So this is A. Now, let's suppose you have a reversible process versus an irreversible process. Okay? So, in an irreversible process, there are dissipative losses. So, the energy is lost, right? So, there is energy dissipation in here. So, energy is lost. How is it lost? It can be friction in the system, it can be hysteresis loss, it can be a viscosity thing that is going on in the system. So there can be multiple ways in which an irreversible process can be losing energy, right? So like more energy is dispersed in here, right? And therefore, when we compare the work done in an irreversible versus a reversible process in any kind of system, it can be isothermal, in any kind of system in which you are just comparing the nature of the process, right? Whether it is reversible or irreversible, due to the energy losses in the system, an irreversible process will always give less work. Okay? So always, whenever you have the comparison between an irreversible and a reversible process, an irreversible process will always have less work. Now, an example of an irreversible process, how can you make that irreversible? If there is a sudden change in the pressure, right? For a reversible pressure, the piston, so like suppose you have a piston in which the pressure is applied, the pressure is decreasing, but the pressure is decreasing very slowly, following the reversible process laws. In that case, you will have more work done as compared to an irreversible process in which if you have a system and you just remove this, like the piston very fast, right? So if you do that, that is an irreversible process. In that case, you have less work done. We'll show that mathematically how in an irreversible process you have less work done as compared to a reversible process.